So the structure of your final solution will kind of naturally progress on from this screen design and through with decomposition. And one of the reasons why I get you guys to do the decomposition and the screen designs first is so you've got a really good idea in your head what your final solution is going to look like. If you know what it's going to be, then actually starting to find functions and objects, things like that, becomes much easier. Long and short of it, the better your decomposition, okay, the clearer need there will be for having functions and knowing what those functions will be, what they do, what their algorithms are, etc., etc. So it's actually a natural progression onwards. Now, I strongly suggest that you structure your solution using OO coding techniques and designs. My reason for this is that it's absolutely amazing practice for your exam. Okay, OO coding comes up quite a bit in the certainly paper 2, and if you have practice by actually doing it on your coursework, then you'll understand the principles such as encapsulation and how to use objects, how objects interact with each other, etc., much better. We don't do a huge amount of OO coding in the course, even though it is on there and we do spend some time doing it. In reality, OO coding is not something you learn in a couple of weeks. It's something you develop over a long period of time. So the more practice you get, the better it will be for you. So that's the reason. However, you don't have to, okay? What you do have to do is make your code modular. So you could just simply use a lot of functions and get the functions to talk to each other. That ultimately, that choice will be up to you. So in the next session, we're going to be looking at how to use classes, looking at the attributes, methods, and any inheritance might come along. So how do we find classes and objects? Well, there are a number of aspects that you want to think of. The first off is any databases you might have and in structure. So you remember we have the model view controller, which I introduced in a previous section in decomposition, where you have the model, which is your database, which will talk to a controller, which will in turn talk to the view. Now the view will talk to the controller. I'm not sure why I did it as a circle, because it's not really a circle. And then the controller might talk to the model. So essentially, we've got this communication between the view and the controller and the model. The model becomes a database, so it makes logical sense to have a class which is just handling all the database stuff, or all the file handling stuff, or all the storing of any form of data stuff. Okay, so that is a single class. So we've straight away got a class. That might be called, I know, database controller. Okay, so a database controller, then you have your main controller, things like that. Every screen should have their own class. Okay, I can't stress that enough. Okay, so one class per screen. Now that is really good design practice, because if every screen has their own class, they then become independent of one another. So you can design them and create them separately, and then eventually link them up to the controller. Okay, so it's very common to do that. If there's any components on the screen that you have to code yourself, now this one is going to be a bit more dependent on your project. There might be something very custom that you have to develop, maybe something like, I don't know, a webcam, your screen and stuff like that, I don't know. That may be the case, may not be the case. The one place it probably will be the case, and I'll put this a separate topic, idea straight off the bat, is sprites. So every sprite will have a class. So you got your player, maybe have your enemies. Don't know why I was trying to spell it with I there. So your enemy. You might have multiple ones, so that might involve a little bit of inheritance as well, etc., etc. You're going to have a controller. Okay, the controller's job is really to kind of manage all the game logic, all the business logic, and things like that. So its job is to talk to the model, to store stuff. It's going to get messages from the view to say, do stuff, like this button's been clicked, handle it please, and then it will send any information back to the view to be displayed on the screen, maybe a message or whatever happens to be. And then finally, game apps. Game apps are a classic one as well. Not sure what's gone down there. GameMap's a classic one because they effectively are the data structure of most games. So you'll have maybe a map which will have tiles or whatever happens to be, and that will be ultimately a separate class as well. These are just ideas, guys, okay? They're not the be-all end-all. You might have other classes in there, but the most common ones for a GCE coursework that I can think of. So, although it's not on the spec anymore, class diagrams are actually really important. Now, it doesn't anywhere say you need to know class diagrams, but if you actually look at the exam papers, you'll notice that they exist and they are in the exam papers as examples of what a class looks like. They're dead easy, okay, so they're not hard to understand or draw or anything like that. So having an awareness now will help you with exams as well. Also, it's a really quick way of showing what class there are. So you'll have in a class diagram essentially a box for each class you have. Inside it will have the name of the class, okay, that'll be whatever you call it. It will have its attributes, and these are all the things that it will store, and then finally its methods. Okay, and it's just a very quick way of showing what are the attributes being stored inside it, what are the methods, so we know what to call. I'll go on to in a bit and say how you actually properly figure out what attributes or methods are going to be stored in each class, but for now that's the kind of idea. If they talk to each other, then it's going to be a line between it. Now, at this stage of the course, I don't expect you to be properly putting something known as conditionality onto it or anything like that. So don't worry about that or the special types of relationships in the UML diagram. Not important. A line is absolutely fine, just to show that they will talk to one another. It's a bit like when you do an ERD diagram, you show a line. The only difference is you don't need to worry about crow's feet. Okay? So let's move on. So every screen must have its own class, okay? That is fundamental. So if you've got a game screen, for example, or you have your main kind of game loop, for example, and that's going to have a screen that's going to be displayed, that will have its own class. So what goes into this class? Well, really simply, anything that is a text box, anything that will be maybe a button or anything that you can interact with or be displayed on the screen will become an attribute. So let's say I have two text boxes, each one of those would be considered an attribute. The data type of those will obviously be very dependent on the library you're using, but at this stage for design, if you just put text box, that's fine. Methods will be anything you can do on that screen. So if I can, let's say, imagine I've got a flashcard system and I could have a little thumbs up button, which I can like my flashcards. One of the triggers will be clicking on that like button. So like a card. Okay, so I might call it something like card or something like that. And I might have another one called dislike card, and I might have one say next and back. Yeah, so basically anything you can do, any actions that will occur based on you interacting with that screen become the method. Now those methods might do some basic validation, but they won't necessarily do much, okay? You'll have a link to a controller class. Now this will be a separate class, and inside that method you will also have a corresponding method, okay? So the controller have methods provided functionality for whatever you've clicked on. So I'm going to show you what I mean on the next slide. Okay, so imagine I've got a screen, okay, and on that screen it has our like button, okay, so, and then it's got my dislike button, okay, I don't know. Okay, please do not have a go at me for my bad art. It is what it is. Okay, so that's the thing, and let's call this screen, I don't know, view card. So my view card screen will have two attributes on it. It will have a like button, BTM for short, and that has a, it has a attribute of button. It will then have a dislike. I'm not sure why that's happening. Dislike, BTN, and that has a date type button as well. So those are the buttons themselves. Then we'll have the methods. Okay, so the methods in this case will be like card and dislike card. Now, we probably need some other information on here. So what's the ID of the card? Because maybe this is going back to database. For now, we're going to ignore all that. We're simply going to keep it as simple as possible. So this becomes my class diagram. Okay, very messy one, but it's there. And then I have my controller. And my controller's job is actually to perform the like. Okay, so let's call it controller, CTRL. Okay, then for now, we're not going to worry about any attributes or anything like that, but what we will have is a method called a like card. Now, it's absolutely fine to call it the same as the view, okay, dislike card. Now, what's going to be the difference? Well, I probably need to pass some information through it to say which card I like and dislike. So I might just take that bit out there and I might put in an ID. Okay, the ID being, well, which card do I like, which one don't I like? So that becomes my object, my class for the controller. Now inside this controller, you're going to have all the actions that you might have. Sometimes when I've been designing for big organizations, they will have a controller per screen. You don't have to do that. That's probably a bit overkill. So here I've got my relationship between them. So what happens? What's going to happen? So I will click on a button. Let's say the like button. Okay, that's going to be linked to this method here. Now on that method, in this case, it's probably not going to do much, but it might be that I have validation on there saying, have I liked this card already? If so, I'm going to do nothing. If I haven't liked this card, then brilliant, I'm going to like it. That method will then call the method on the controller class, okay? And that will have the job of actually performing the like, actually doing the logic of it. Now, in order to perform a like, I might have to save it to a database, maybe update a record in a database. So maybe there's a card row, I don't know, something like this. So card row, and it might have an ID, it might have the text for the card and lots of other stuff. Maybe have a like count or something along the lines, and I would simply add one to that like count. So this is going to be inside the database, which means I have one last class in this scenario, which is going to be the model. Okay, and I'm running out of room, but I will try. So I'm going to have my database. Okay, and it will have inside it, okay, we're not worried about attributes for this one, but inside it, it's going to have a method called something like card as well, and its job is to update the database. And again, that's probably going to have an ID. Oops. Okay, and then finally, we're going to have this kind of link over to this one. So what's the final procedure? Well, I have three classes. One for the actual screen, one for the controller, which is handling the logic, and one for the database, which is actually doing the saving. So I press the button, it calls a method on the view card, which does any validation. So validation. Then I have my controller, which does any logic. So if there's anything it has to do, I don't know, in this case, maybe update how often that card's going to come up or something like that, I don't know. And then finally, the database will actually perform the actual saving. Okay, so essentially we have this kind of path through the system, and this is a very, very common path. And the long and short of it, this is how you start designing it. Okay, so you have your screen, attributes for the buttons, and then methods for all the things you can do on it. A corresponding method inside your controller where it makes sense, and then if need be, one in your model as well to update it. So Once you have got the design, I strongly suggest get your teacher to check over it, because this isn't straightforward, and the first time you do OO design, it's not necessarily going to be great. If you decide not to go OO design, you're going to have methods and functions. You want to make sure that your methods and functions are modular enough in order to get the marks. Okay, so I strongly suggest before you do any detailed description, check your diagrams with your teacher. Okay, once you've done that, you need to just describe what's going on. Now, this doesn't have to be detailed. All you have to do is say what is the class and what the method's doing. Okay, this part of it you don't need lots of detail. When you do structure write-up, you are going to show the class diagram, show that every screen has its own class, explain the purpose of each class and what methods they are, and then we do data structure design. Now, data structure design, you do have to put a bit more detail in it, and this is where the justifications come in. Okay, so as long as you've done your decomposition justifications, you don't have to do any additional ones for the structure design. And if you think about it, that makes a lot of sense, because you've just done them in decomposition. You don't need to just, justify again what you've just done, because you've already talked about it. So that's the reason why we don't justify the structure design. Finally, ladies and gentlemen, I'm sorry this is a long video, but your data structure design is essentially what are the key variables or the database or the files you are going to be using. Now, for some applications, you can have a database. So all you do is describe the database and say what's there. If you don't have a database, then you're going to be talking about your key variables. Now, please, please, please don't code it. Look at your variables, write down every single variable you've used, and then say why you've got it. That is not design. That is doing it and then tell me what you've written. Okay, that is completely the opposite thing, and you won't get any marks for doing that. What I'm looking for is, well, what attributes have you put into your classes? This is one of the reasons why OO coding actually really helps at this stage, because you've already said what attributes you're going to have. Well, that's your key variables, aren't they? So just describe those. What are they there for? That's it. That is it. That's all you have to do. If you haven't done that and you've done it through using methods, functions, then you might actually want to do this part after algorithm design. Then you've got a bit more idea what variables you're going to need. Okay, so that is up to you. I would do it that way. So if you do OO coding, describe your attributes, job done. If you've done functions, wait until you've done algorithm design and then do data structure design. Okay, so what do you have to do in it? You have to say all your key variables. For each one, you need to say why it's there. That's nice and easy. Justify why you've picked the data structures. No, not why is that data there. Why is it that structure? So for the most part, it's going to be fairly obvious because it's an integer, because it needs to be a number. It's a string because it needs to be a string. Sometimes, however, you do have to justify yourself. For example, if you use a queue, why queue over a stack? If you've used a 2D array, well, why not a 1D array? Why use a 2D array? So it's the more complex structures. So if you use any point, any of the abstract data types, so graphs, lists, trees, that kind of stuff, or you've used a 2D array over a 1D array, or maybe even a 3D array, it doesn't happen very often, but maybe you did. That's the ones you justify and give me a bit of detail. All the others, just tell me why. Finally, any validation use. Now, this is useful at this stage because if you think about, well, okay, this attribute is going to be storing inputs from the user, so I need to do some validation on it. Not only does it give you an idea for your screen design, it also will tell you what you need to code in your actual implementation, and it gives us a signpost of where we can find your validation. Okay, not every variable needs validation, by the way. Some of them don't, like a button. How can you validate a button? Not really sure. Maybe whether we can toggle it or not, I don't know. But for the most part, you won't need that. So it's only ones which actually govern inputs need to have validation. Okay, if it's a game, anything that the user can control, or any kind of interactions that a character might have or an enemy might have, that will probably need validating. So if you have a database, then describe the fields. If it's a relational database, then show the ERD diagrams. Long and short of it, imagine this was a database normalization question. Give me that kind of detail, but then say why. So here's an example of how you might want to lay it out. I like tables, as you've probably gathered. So here I've got my variable, I've got the date type, and I've got my justification. Okay. Here I've got my next one, and I've got my justification. Now, in this scenario, this one, it's fairly obvious it's a string. It should be. I put a justification in there to show you how you might do it. If you're finding there's not much to write about in this section, then you probably want to do this for a few variables just so you guarantee yourself the marks. Okay. Sometimes there are parts of this coursework which are a little artificial. I'm going to say that nicely. So as long as you give evidence that you're justifying yourself, then that's okay. So structure write-up, finally. Every key variable, class, date, structure is present. Each variable must have a clear purpose, a date type, validation if applicable, and justification of why it's got that data structure, not necessarily why you need it. A database of files must be described. So for high marks, we have identified and justified the key variables, data structures, and classes appropriate to the proposed solution, justifying and explaining any necessary validation. Okay, so you notice you need all of that to get into high marks, which is why I have mentioned it all. Hopefully that's all useful, and have a go at data structure design and your structure design.